Hey Primary 3 Math Prodigies, this is Coach Saiful with your daily dose of math mastery, and today we're going to go into assessment paper number 14 where we're going to take a look at fractions, okay? So let's revisit fractions, and I'm going to test you a few things, namely everything from conversion of fractions to putting together ascending and descending forms of fractions, okay? So let's get into the questions first. The first question, if we take a look at this, is express 9 over 12 in its simplest form. Okay, now when you have something like this, when you have something like this, 9 over 12, and when they tell you to make it into the simplest form, okay, let me take a look. Simplest form, okay, what does that mean? Simplest, what does that mean? It comes from the word simple. And simple means to make things easier. Okay, in this case, 9 over 12 is considered a bit weird. It's not the simplest form. It's not the easiest format you can put it in. Okay, form again meaning the easiest look. Okay, so what we can reduce this. This right now is very fat. Okay, it's very fat. As you can see, it's very fat. 9, 12, very fat. Now, what we need to do is we need to slim it down. Okay, make it slim down. How? We must divide both numbers by the exact same number. Okay, so you ask yourself, can this number be divided by 2? 9 divided by 2, does it leave a remainder? Yes, it does, so we cannot use that. How about 3? Yes, we can. So we can use number 3. So if we divide the above by 3, it will not leave a remainder. And if we divide the bottom by 3, it will also not leave a remainder. Now, when we divide the numbers by 3, what do we get? 9 divided by 3 will give you 3. And 12 divided by 3 will give you 4. Now, this is a simpler form of 9 over 12. It's a slimmed down version. Okay? But let's ask ourselves one more question. Is this the simplest form? In other words, can we make it slimmer? Let's try. Can we divide it by 2? There'll be a remainder here, but the bottom will not be. So therefore, we cannot use that. How about if we divide it by 3? On top, of course, it will lead to a 1 with no remainder. How about 4? It will leave a remainder. So therefore, if you try any other numbers, you can't do it. So this is the simplest form. So the answer is, for part A, 3/4, which is C. Okay, got it? Alright, good job. Now for number 2, which of the following fractions are equivalent to 1/4? So as you can see, they've given you 2 fractions in each answer. Half and 2 over 8, 4 over 8 and 2 over 6, and so on and so forth. Now, what your job is supposed to identify, to look out for which of these are the same as 1/4. So let me give you a clue about this one. Okay, for this one, oops, what happened? Okay, oh no. Okay, for this one, what they're asking you is, can you give me the other versions or the other forms, or in other words, can I say the fatter forms of 1/4? Okay, so if we times 2 here, we will get the same one, but only in the fatter version. So 1/4, 1 times 2 gives you 2, 4 times 2 gives you 8. So these two are actually the same, but this is the slimmer version and this is the fatter version. Very simple. Now what if I times 3 instead of multiplying by 2? So instead of 2, I multiply it by 3. Okay, I will get an even fatter version of 1/4. So in this case, I will get 3, and 4 times 3 gives me 12. So this is an even fatter version of it. Now, I can make this fat as I want, okay? But I'll have to change number here. So instead of 3, let's do 4. Okay, so very simple. So 1 times 4 is going to give you 4, and 4 times 4 is going to give you 16. So this is the fatter version. Can we go further? Yes, can. Now I'm going to ask you what number we are choosing. Alright, we're going to choose number what? 1, 2, 3, 4, and very good, 1 times 5. And what you will notice is that it's still the same thing. 1 times 5 gives you 5, and 4 times 5 gives you 20, and this is an even fatter version of 1/4. So let's take a look at the numbers. 2 over 8, 3 over 12, 4 over 16, and 5 over 20, and let's take a look at our options. 2 over 8, half is not. Okay, good. 2 over 6, is that what we have? 2 over 6? No, 2 over 8, so wrong. 2 over 8 we have, yes. And 3 over 6. No, we do not have 3 over 6. And that brings us to the last option, which is 3 over 12 and 2 over 8. Do we have both? 3 over 12, yes we have, and 2 over 8, yes we have. So the answer for the second one is D. Good job if you got that one right. Okay, the next question is easier. It asks you how many 6 are there in 2 over 3? Now, here's the trick that they're trying to put on you. They're asking you how many sixes in a number format is going to actually look like this, over 6. So 1 6 is 1. So if 2 sixes means it's 2 over 6, like that lah. Okay. Now the question is, however, how many sixes are in this one? So what do? You make it into a fatter version. Very simple. You multiply by 2. You multiply by 2. Why do I multiply by 2? Because I want to get the bottom to be 6. And 2 times 2 gives me 4. So how many of sixes do I have? In other words, how many 1 6 do I have in 4 over 6? I have 4 sixes. So the answer is, the answer is, oh no. Okay, the answer is D. Good job if you got that one right. Now number 4, a skirt costs twice as much as a shirt. If the skirt costs $48, what is the cost of the shirt? So let's take a look at this. A skirt costs 3 times. Okay, I'm not going to use models. I'm not going to use models. I'm just going to draw it for you. Okay, a skirt costs 3 times of a what? As much as a shirt. So 3 skirts will be 3 skirts will be the same cost as a shirt. Correct or not? Yeah. 3 skirts will be the same as 1 shirt because it's 3 times more expensive. Okay? Wait a minute. A skirt costs twice as much as a shirt. Okay, I think I'm wrong. It's definitely the other way around. Therefore, 3 shirts is going to give me 1 skirt. Okay, I think this is too confusing. Let me just draw it out in the model because it's so much easier. Okay, a skirt here and a shirt. Okay, see properly, shirt and skirt. Okay, skirt costs 3 times as much. So if I draw a model, what will I get? I will get a model with 3 units, being 1, 2, and 3, and the shirt being only 1. That means the skirt costs 3 times as much as a shirt, correct? Yes. Now the question is, if the skirt costs $48, what is the cost of the shirt? So you take a look here. If the skirt costs $48, okay, let me ask you a question. How many units do I have? I have 3 units, am I right? Yes. And how much does 3 units equal to? $48. So if I want to find out what is the cost of the shirt, which is in this case 1 unit, all I have to do is find 1 unit. So 1 unit is equals to what? 48 divided by 3. Which gives me what? 16. Okay? So that is the answer for number 3. Am I right? Number 4, sorry. What is the cost of the shirt? The answer is 16, which is option D. Okay, the next one. Which of the following fractions is the smallest? 5 over 6, 3 over 2, or 2 over 12? Okay, I'm going to write this down again. Is it 5 over 6, 3 over 2, or 2 over 12? That's the question, right? Now, the thing is, all these look different. Why? Because their denominators or their bottoms are different, you see. So what must we do? We must first of all make it all the same. Why? Because we want to compare. We can't compare if the we can't compare let me think. We can't compare how fat someone is if they are all wearing different size shirts. Of course, the person wearing the very small shirt will look super fat because he's wearing something superbly tight. But if he's wearing something very, very big, he will not look as fat. You get what I mean? So similarly, we must put on a very similar shirt. So in this case, we have 6, 2, and 12. Now, what do we change it to? We change it to something that is the same. And in this case, what's the biggest? It's 12. So therefore, we must times 2 to the 6 to make it 12 and times 6 to the 2 to make it 12. Now everybody is the same. Okay, and of course, we must be fair to the numerator. If we multiply 2 to this fraction, to this denominator, we must multiply 2 to the above. If we multiply 6 below, we must multiply 6 above. 5 times 2 gives me 10, 3 times 6 gives me 18, and 2 over 12 is still 2 over 12 because we're not changing a single thing. So which one is the smallest? The smallest is 2 over 12. Simple. So that's the answer. And finally, for question number 6, arrange the following fractions in descending order. 2 over 3, 2 over 9, or 3/4. Okay, 2 over 3, 3 over 9, or 3/4. Now, what is descending? It's a big word, isn't it? Descending, I'm going to give you a clue, is you take a look at D, the letter D, okay? And I want you to just imagine the D being down. In other words, you must arrange the numbers in such a way that they are going down, which gives me the biggest first, the next biggest first, and the smallest last. So in other words, I'm saying arrange it from big to small. So this equals to big to small. Very simple. Now, here's my next question. Now, how do I know which is big and which is small? If we learn from the previous example, what we need to do is we need to actually make sure that the bottom are the same. Okay, this is a bit more difficult. So what I'm going to do is I'm actually going to change this number over here to 12. Okay, this is not in your syllabus, so I'm going to change it to 12, 3 over 12. Okay, now what should I do now? What I should do now is that I should change the numbers to look the same. So in this case, 12 is the biggest, so I choose that to look like the rest. I choose that, yes. So therefore, 4 times what give you 12? 4 times 3. 3 times what give you 12? 3 times 4. And of course, we must be fair to the ones on top. So we multiply 3 here, and we multiply 4 above here as well. In this case, we don't multiply because they are already the biggest. So what we have is 2 times 4 gives you 8 over 12. 3 over 12 remains, and the last one, 3 times 3 gives you 9 over 12. Now here's the question. Do I write down 3 over from big to small, right? So 9, 8, and 3. 9 being the biggest, 8 being the next biggest, and 3 being the smallest. So do I write 9 over 12, 8 over 12, and 3 over 12? No, I must write down the original form of the fractions. In this case, I must write down the answer is 3/4, 2 over 3, and 3 over 12. So that's the first 6 questions of this assessment paper, and if you get all of them right, I'm very proud of you. I'm going to give you a big high five because you are a math prodigy. Good job. Really awesome. Alright, so that brings me to the quote of the week, and the quote of the week is this. Do more than is required, and you'll get what is desired. So what do you desire? You desire to score high in math, or in school, or in life, wherever it is. You want to win, don't you? Now, to get that, you need to do more than is required. It's simple. If I tell you to do 3 questions, you do 6. If I tell you to do 5 questions, you do 10. You do more than is required, and you'll definitely get what is desired. That is my belief. That's what I've seen in my life, and that's what I know will happen in yours. So do more than is required, and you'll get what is desired. With that, this is Coach Saiful signing off, saying you are a math prodigy. Good job.